Okay, welcome to the video on derivatives using data. Really using a table for this. Also, in this video, but later on, I'm going to show you how to find the derivative of a function using your calculator only. So look for that a little bit later on this video. So what we're going to do is we're going to answer a bunch of questions involving derivatives when we're given a table. Okay, so here's our problem. We have water flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function, W, for t's between 0 and 24, where t is measured in hours and Wt is measured in gallons. Values of W at selected values at time t are shown in the table below. Okay, so part A, we're going to use the data of the table to approximate W prime of 15, and we're going to show our computations, and we're going to use appropriate units, and we're going to explain what the heck this means. So W of 15, we don't have that in our table, by the way. So it's somewhere in here, a little bit closer on the 16 side. So to approximate a derivative is a rate of change. A derivative is a slope. So to approximate the slope at 15, I have to do my rise over run using the values that I'm given. Okay, so to approximate this, so W prime of 15 is approximately the rise over run. We're going to be using the t equals 16 value and the t equals 12 value because that's 15 somewhere in between there. So if I find the secant of this, it's approximating what the tangent is going to be. So I'm going to find out what W of 16 is minus W 12 over 16 minus 12. You do need to show this work. Absolutely. If this is a 2-point problem or a 3-point problem, this is probably going to be worth one of your points. Okay. Usually these problems are worth 3 points. So I'll kind of point that out as we go through this. This is 1 point right here. Okay. Now, what are these values? Well, I'm going to get 294 minus 257 all over, well, that's going to be a 4, which is going to give me 37 over 4. Now, usually these are calculator problems whenever you're given stuff like this with a table. Sometimes it is, sometimes it isn't, but typically in the past they have been calculator problems. So this is the same thing as 9.25. Now here's the important part, the units. It says using appropriate units. Now, W represents gallons, and then the bottom represents time. So it's really gallons per time. And what the time represented as hours. So this is going to be gallons per hour. Okay. Now, here's the great thing about calculus for when you take the AP exam. You don't need to go from here from 37 over 4 into this 9.25. You can actually just leave that as this, and you'll get full credit. Okay. So just be aware of that. You don't need to, but I just showed that just so you can kind of get an idea that it's changing at about 9.25 gallons per hour. Now, okay, what does this actually mean? I'll write this in gray because I'm kind of running out of room here. So whenever you need to explain the meaning of a derivative, you need to state the time, you need to state the rate, and what the rate represents. So here we go. So at time 15 hours, or you could just say at 15 hours, totally fine. Now, what's actually happening right now? The water is flowing into the tank. Okay, so that's what's going on, and I know that right from here, from reading this part up here. So the water is flowing into the tank, or the tank, doesn't really matter, at a rate. Again, you have to specify that it is a rate because we're finding a derivative of it. At a rate of, so rate of, and then here we go, 9.25 gallons per hour. All right. And there you go. So this is what this W prime of 15 represents. Okay. Now let's go ahead and look at B now. So let's use the data in the table to find the average rate of change. So average rate of change is going to be the same thing as the secant. So it's really going to represent the same thing here. But the difference between A and B is for A, I had to figure out which two values to use. Whereas now, they're giving us, use these two values. So the average, do this in red. So the average rate of change is going to be W of 20 minus W of 4 all over 20 minus 4. Okay? So again, you need to show this. This is 1 point right here. You do not show this, then you can lose points. And this is equal to 327. I'm just looking at my chart right now. 327 minus 184 all over 16. And then this is going to give me 143 over 16. You can totally leave this. Totally fine. If you want to go further and use your calculator, that's fine as well. So this is going to be 8.9375. The reason I write, you're going to always have to write 3 decimal places. The reason that I'm writing 4 is just to let you know that for this third place, you can either round up or you can truncate. So we will accept answers of 8.938 or 8.937. We'll accept both of those answers. You can truncate or round for that. So I just write the fourth one right there just to show you what that fourth one is, so you can know that, hey, if you want to round up, it could be an 8, or if you don't want to round up, stick it as a 7. So it's totally your call. All right. So before I mention how I'll kind of go over the points for this, now in a free response, they're going to ask you both of these. They'll either ask you A or B. So if they're worth 3 points, writing out the formula, that's 1 point. And then the answer is usually another point. And then units are another point. So especially if they say use the appropriate units, it means that that's going to be worth a point. So you have to use the units, but they don't have to say this part, using the appropriate units, to make it a point. All right, so just kind of be aware. So that's 1, 2, 3 points, and then since this one asks explain your meaning, that'd be another point right there. So part A would be a 4-pointer, whereas part B, this could be either 2 or 3, depending. Again, you're going to get a point here in the setup, and then a point on the answer, and then they don't specify units, so they may or may not tack a point on there for the units. Okay, part C. So for T between being 0 and 24, must there be a time at which the tank contains 265 gallons of water, justify your answer. So is there a time in here where it's going to be 265? Now, it doesn't actually say it. I don't see 265 in here, but somewhere, hey, what a coincidence, it's going to be in this space somewhere where it looks like it's going to be 265. Now, we don't necessarily know if this is always increasing. It did not say so. Okay, so, but I do know this is continuous because it says it's differentiable. Differentiable is like the hidden word for it's also continuous. So if you say something's differentiable, it covers continuity as well. So because of that, I'm capable of using IVT. So yes, this happens. That's a point. Then you actually have to go by write everything else. So by IVT, you don't need to specify IVT. I'm doing it because it's your notes. And what are the 3 things we need? Well, I'm going to write that the water flowing into a tank for 0 to T is continuous. So again, for IVT, I'm just saying that the function is continuous over that interval. That's all I'm putting there. Could you have written down WT is continuous over this interval right here? Totally could. All right, and I don't know why I underlined my 0. Not redoing the video. Part 2, you say that the endpoints are not equal. So, well, W of 24 is not equal to W of 0. And then the third part is now saying that, well, 265 is between W of 0 and W of 24. And that will give you full points right there. So you're actually going to have to write out all that stuff as we go through. All right, good so far? All right, and I think we're going to get to the part where I'm going to start showing you some of this calculator stuff. Okay, so this is the same problem, same prompt, just 2 different parts. So now a model for the amount of water in the tank is given by this. Okay, so they're showing you just a different model. It could be a different tank. They don't really specify that. Where A of t is measured in gallons and t is measured in hours. Okay, find A prime of 15. Now, since this is a calculator problem and they're giving you a calculator in your hand, you can use your calculator to find this derivative. Okay, so could you by hand do this, distribute this, and then find the derivative of each of those individually? Totally, but let's not do that. So calculator is actually going to be on my phone. So here we go. So what you're going to do for this is I always put everything in Y1. That way it's easier to recall. So I'm literally just going to type this in exactly as I see it. So negative, don't forget to use the negative sign, not the actual minus sign. Also, we don't have t's in our calculator, so we can just use x's to represent it instead. Okay, so I have the entire function. I'm going to just double check it. Looks good to me. So there's the entire function. Okay, so now I can just recall this as y1 every single time. Okay, so to find the derivative, the magical derivative button is in a couple different places, but what I'm going to use is in the green. It's going to be F2. So you hit alpha F2. You get all these choices depending on what calculator you have. Some calculators will give you more choices, but I just care about choice number 3, the derivative. And this is what I want to pull up. Okay. Again, alpha window, which is F2, derivative. I'm just going to go down and select it, choice number 3. It's also in math. If you go into math and you go all the way down here, it's choice 8 as well. It'll pull up the exact same thing. It does not matter. So again, I use the F2 shortcut. And now this part says, what's our variable? Variable is x. This part is, what function are we taking the derivative of? Well, I already typed it all in. Now, could you type this into there? Totally could. But I already typed it into y1. So to recall y1, again, using my hotkeys, I'm going to use F4, so alpha F4, Y1. All right, if you get a little confused on this, you can totally watch this part of the video again so you can catch everything. And where are we evaluating it at? Well, we are evaluating it at 15. And then, bam, pretty easy, right? So what you're going to do, because you have to show this work, you can't just write 9. Okay, so you're going to do d over dt of a of t, evaluated at t equals 15 is equal to 9, and then units are going to be gallons per hour. Again, so I'm going to use the correct variable when I write this down. So it's, instead of x, I had to use x in the calculator, but it's really t, and this is the function a of t, and I'm evaluating it at 15. That's what this line means, by the way, is evaluating at whatever that is. And that's enough work. Okay, that's showing the grader, okay, you did this in the calculator, you didn't just make anything up. So that's the work that you need to show. So whenever you use your calculator in a problem, you need to write everything down on your paper that you're doing in the calculator. Okay, so I'll clear that. Next part, use the model to find the average rate of change. So now we're using this model A instead of the table now. So the average rate of change. This does not change whatsoever how we write this part. It's going to be A of 20 minus A of 4 over 20 minus 4. Same thing as we did the part B, but instead of W, this one's A. And this one you can do purely in your calculator. Okay, I already have the function in Y1, so let's go ahead and use that. So I'm going to go to alpha F1. Lots of hotkeys coming up here. You have to be pretty fluent with this, with your F1s, F2s, F3s, F4s, F5s. If you're not, math button has almost everything. And actually, let me just show you. If the different way to get the Y1 is this button that says variable. Bars means variable. That can also, you can also pull up the variables. So you go to the Y variables, the function, and then you can pull up Y1 that way. Anyway, so alpha F1, enter, gives me the fraction. I'm going to pull up Y1, parentheses 20. So I'm pretty much typing in exactly what I wrote down. Minus A of 4 all over 20 minus 4. And then you can enter, and that does everything for you. This answer is perfectly good. So if you happen to want the decimal version, if you just go to alpha F1, you can convert fraction into decimal with that last choice right there. And this is going to be 8.995 or 6, doesn't really matter. I was going to write 55 for you. And this is going to be gallons per hour. So that is derivatives using data.